Okay, so I want you to draw 3 different graphs of a continuous and differentiable function that passes through the points A and B. Continuous and differentiable passing through A and B. Okay, talk to you. Okay, part 1, send somebody to draw one of your graphs. Part 2, send someone to draw one of the graphs. Part 4, send someone to draw a graph. Part 5, send someone to draw up a graph. Probably not Zach because he's.
I'll go.
Mentally drew them.
I'll go, but I'm gonna wait and see. I don't do something that someone's already done. You go first.
No, you're wrong.
Hey Carter, how many slides is this?
11.
Oh.
Like, yeah,
Is it a loading slider? Not the slider.
Ooh. Oh, man.
All right, Brady, you draw a stick one.
Oh, you want it on this? Oh, you should down the graphics already there.
Yeah.
You can see your second corner.
Oh my god.
Isn't that one of those questions?
Okay, within your pod, I would like you to please discuss what all 4 of these graphs, as well as any graph that you drew, what do they have in common? Talk amongst your pods. Other than that.
they are all.
Positive and negative.
Maybe think about like some calculus stuff, since that's, what we're talking about.
Oh, I thought you were just saying in general, like, how the X we can.
Carter, I'm going to draw a counter
What?
counter example. That's not crossing the x-axis.
Why? Why?
They are because we have continuity, okay? But calculus-wise, I heard some good discussion.
They have to have a minimum max.
Okay.
What if you drew
Okay.
It's not
That,
differentiable.
this isn't differentiable.
Because it's the instantaneous rate of change always just as 0.
0. Okay, so instead of saying there's always a min or a max, because that was true except for this just one particular case, what's true about a min or max? Its derivative. What's true about this derivative?
The derivative must equal 0.
Okay, at some point between A and B, there has to be a time when the derivative the derivative is 0. Right? Perfect. That is Rolle's theorem. You all just discovered Rolle's theorem. If we have a continuous curve that is also differentiable between A and B, if A and B are at the same height, f of A equals f of B, then there is at least one time between A and B where our derivative is 0. There could be more, but there has to be at least one time where that derivative is 0. It is important to remember two conditions. Our curve between A and B must be
Continuous and differentiable.
continuous and differentiable. If our curve is not continuous and differentiable, then we can't use Rolle's theorem.
I think that's just kind of like a common sense thing.
Well, I mean,
Hey.
okay, somebody who doesn't know calculus, would they be able to put up with this?
Yeah, yes.
Is there any relation? If they knew about derivatives, then yeah.
Okay, so if you know anything about derivatives and what they mean, then some of you may think this is common sense. So what you're telling me is it should be an easy concept for you.
So, why did he get his second name on the stem? Let's not go there.
Okay, so show that there must exist a C value where the derivative is 0 on the interval from -1 to 3.
Set it equal to 0.
Okay, now, if we are going to use Rolle's theorem, we have to make sure what?
It's continuous.
Okay, are we continuous from -1 to 3?
Yeah,
Are we differentiable
I believe so. Yes.
from -1 to 3? It's polynomial, okay, those are, it's an easy example, right? So, what's f of -1?
0. 3. Yeah. 3.
What's f of 3?
3.
3. These have to be the same in order for us to use Rolle's theorem. So we know that between -1 and 3, there is an x value that when you evaluate the derivative, it is 0.
That's 15.
Hold on. Okay. So,
Must be probably.
how are we going to find it? Okay. So, what is our derivative?
2x minus 2.
And when is our derivative equal to 0?
X is 1.
Okay. And, hey, cool, look at that. 1 is between -1 and 3. We knew there had to be a value. Okay? So, our C value that they were asking for was 1. That's the X value. Okay. Now, is it possible for, like, if this was a cubic function, let's say, it would be possible for us to get 2 critical points, correct? And so make sure that you pick the values that are in your interval, because if there is more than one min or max, or there is more than one time where your derivative is 0, it's possible that one of those points is not in the interval that they're talking about. So make sure you look at that. Yes.
So what is the application for why?
Well, we're going to talk about the mean value theorem, which is probably more important. Rolle's theorem is kind of like a special case of the mean value theorem, and it's something that's easy for you guys to see right now. As far as application,
Well,
I mean, I know.
Even just within calculus, all this does is really just confirm you've got how many f times c equals 0 between these 2 points.
You know, I suppose that if you were doing like our graphical analysis, this would be something that if you had 2 points, you know, you would know that you better have a minimum or maximum in between those 2 points of equal height. You know what I mean? Technically, this is section 2 of chapter 3. We kind of like jumped back to the beginning of the chapter. So as you're going through your curve sketching, if you have 2 points that are equal, this is something that could be a red flag if you don't have a minimum or maximum in between those 2 points. Does that help? Okay. Okay. Rolle's theorem. I want to know where we have a derivative of 0 between -8 and 8. If we're going to use Rolle's theorem, what must we check before that? Continuous and differentiable. Is this a continuous curve between -8 and 8?
Yep.
Is it a differentiable curve between -8 and 8?
Of course. Because there wouldn't be.
How would we know?
Find it.
Well, let's talk about the derivative. What is the derivative? Ooh, x to the -1/3. We can't have a 0 in the denominator, which means there would be a what? Where? There'd be a cut for a corner at x is 0.
So do we just box the whole thing?
So we can't use, this is not differentiable. At x is 0, which is in that interval, so we cannot use Rolle's theorem here. It does not apply here. Because it's not differentiable. What?
Is the mean value theorem and say if we have 2 points of different heights, that there has to be a point between those 2 points?
They're going to be at different heights, but there's going to be a point with a different stipulation. It's not going to be necessarily to the root of 0.
Okay, so it exists.
Yes, yes. Keep thinking. Okay. So your turn.
Are those supposed to be closed intervals?
Yeah.
You know, if you're trying to get
That's
a
the
deal.
question.
Okay. Is this continuous and differentiable? Yes. What is f of -2?
0. D. Oh, sorry.
What's f of 2? 8. What are the x values where we have a derivative of 0?
0.
Yeah? Okay. Any questions? All right. Next, for the mean value theorem. What do you think of when you hear mean? Average. Do we have any words that we talked about in calculus with average?
Standard deviation.
Calculus.
No, meaning average rate of slope.
Average rate of change.
Average rate of change. What is average rate of change? Okay, so the mean value theorem. We have to be continuous and differentiable once again. Okay. The mean value theorem basically says between 2 points, the average rate of change is the same as the instantaneous rate of change.
That's
So-
at the midpoint. All right.
Not at the midpoint, somewhere.
Ooh.
Somewhere between A and B, the average rate of change will be the same as the instantaneous rate of change, okay? So let's recall, average rate of change is the slope between 2 points on a curve, okay? Instantaneous rate of change is the derivative.
What I saw was the instantaneous rate change equals, what'd you say?
The instantaneous rate of change equals the average rate of change. So our job is going to be to find where that occurs. Okay. So let's talk about what we're going to have to do to prove this, or to find these values. Okay. So we're going to have a function, and we're going to have 2 points.
And the slope of the secant.
First, we're going to have to find the slope of the secant line. So we know this. Okay.
We're going to have to find our derivative and then plug our slope into our derivative and find where it equals such.
Okay. Then we're going to have to find our derivative. And we want to know where the derivative equals that slope of the secant line. Okay, we want to know where those slopes are the same. Okay? So, turn to your neighbors and in your own words describe what we're going to have to do.
We're losing points for that.
Like,
Trust software where everything.
Okay, we'll come up with something. Now that you have it.
I guess you're gonna have to find Question is,
You just need to come.
because it's the average.
Where the derivative of the change line
Average because of the average. Sometimes,
A good artist Joel.
sometimes they use letters to write that.
I started thinking that might be characters from there, and then in the Hangover.
A lot of
like
this
the
is-
Andy
a lot of
character.
this is
You ever watch the Hangover? He's the one with the glasses. Yeah, but then
Okay. So,
and then he's in
here we go.
New Vacation.
What is the average rate of change between 0 and 1 of x squared plus 2x minus 1? What do we do? Okay, what are our coordinates? F of 0 is?
2 common negative 1.
We plug 0 in and get negative 1. It's amazing how many pencils are moving right now.
I can do mental math too.
Okay? And so our average rate of change would be,
3/1.
why is it what?
No, it's not.
Okay.
Hey, it's fine.
That got scary.
So our average rate of change, y minus y over x minus x. So our average rate of change is 3.
And the derivative.
Okay, so now what we are going to do is we are going to find a number between 0 and 1 where the instantaneous rate of change is the same as the average rate of change. Okay, we found our average rate of change. How do we find our instantaneous rate of change? And what is the derivative?
2x plus 2.
And we want to know where 2x plus 2
Equals 3.
Oh, no.
And then we use algebra.
How are we gonna? I don't know how to solve that. It's so long.
what is it?
That's 2.5. Geometry's terrible.
Okay. And 1/2 is between 0 and 1. Okay.
Oh, yeah. Can I go with that?
Graphically.
Do you know what a funny is?
Oh my god.
Crosses the diagonal.
Let's see. What were our, we had 0, negative 1. And 1, 2. So we know it's a parabola, right? And so our average average rate of change is the same as the instantaneous rate of change of 1/2.
Absolutely.
Wow.
There's so many lines.
How much?
It's actually just pretty hard.
No, there's
Five, six,
Are you considering the green a line?
Oh.
It is more of a curve.
Oh.
It's not hard though, because it doesn't keep continuing.
That's what she said. She said it wasn't important.
I like you for going, I like
It's
this.
a red.
Okay. Mean value theorem for f of x is x to the 2/3 on the interval 0 to 1.
Hey, what is that x equals 1
I don't think it
Does that mean that that's where like the point where, or that's just like the instantaneous?
That is the x value where the the instantaneous rate of change is the same as the average rate of change.
Okay.
That is where our derivative is 3. And we found that because our average rate of change is 3.
I just didn't know what their x equals 1.
All right, so before we use the mean value theorem, though, what should we check?
It's not
Differentiability and continuity.
Is it continuous from 0 to 1?
So,
It's continuous.
Is it differentiable on the open interval?
Is it double?
0 to 1.
Yes. That's question.
No, there's zero, Nathan.
no.
Put zeros that included.
Yeah, it is.
Where is it not differentiable?
Zero.
At 0. We need to be differentiable on the open interval.
Oh,
I knew that.
So we're okay. All right. Now what do we need to do? Okay, we need to find our average rate of change, and to do that we need coordinates. What's f of 0? What's f of 1?
1. Right? Go home. Slope is 1.
So our slope is 1. Our average rate of change is 1. Now what? Our derivative is
3 times x. 3 times
3 halves.
2/3.
You said that earlier too.
Between that one.
Right? So we want to know where, I'm going to write this as 2 over 3x to the 1/3 equals 1.
I don't want to do it.
Is x in a denominator helpful?
No.
So let's multiply it over. Is that allowed? No? You don't like this?
The cubit.
Okay. So at x is 8/27, which is between 0 and 1, our instantaneous rate of change is the same as the slope of the secant line between 0 and 1.
How'd you say it was?
Because our average rate of change
Oh.
on our interval is 1. Right?
Is Lahapidal, is that like a guy's like last name, or is that like his first name?
Last name.
Technical one correction. It says to find C for us.
So really, z equals 8/27.
I know the AP test will kill you.
Well,
I mean, and actually murder you for it.
this is probably not something that you're going to see on a free response problem.
Maybe not.
And this would be a multiple choice problem. Okay. All right. So Rolle's theorem and mean value theorem.
Rolle's theorem is such an equal to 0. I think that.
Because the average rate of change is the same
Oh, okay. How about everybody stop talking? Zach just said Well, on Rolle's theorem, our points are at the same height, so what's our average rate of change?
Zero.
And what were we setting our derivative equal to? Zero. So really, Rolle's theorem is just a special case of the mean value theorem.
Why didn't we do the mean value theorem first?
Why didn't we do this in the first place? That's what was the
Here's your homework.
That's not